The lab for this week was about bar magnets. Within this lab, we wanted to measure the magnetic field of a small magnet from different known distances from that magnet. We had different distances and measured data for both on-axis and off-axis from the magnet. In this lab, we operated under the assumption of a few different laws. The Biot-Savart law, which is the magnetic field produced by a current-carrying wire with the equation on the right. The fact that a magnetic field acts like a dipole, which is that the field magnitude decreases as distance increases and how it acts similar to an electric dipole. And again, that the magnitude decreases as distance increases. First, we had the phone's magnetometer facing properly so that it was orthogonal to Earth's magnetic field. Then we found the location of the specific phone's magnetometer through calibration, and then throughout the experiment we recorded readings and corresponding distances. And then here is the table and graph created from the measurements from on-axis readings. And then here are the readings and how the setup was, how the experiment was set up for all of the off-axis readings. And then here is the glow script code. The one on the top is the general setup for the calculation of the magnetic field, and then the bottom is setting up the visualization of it, and then the right is the final visualization. A few assumptions were made after the lab was completed. First was that the bar magnet acted similarly to an electric dipole, and that the magnetic field did decrease as the distance increased. Several observations were made throughout the experimental process. When the magnetometer was far, the magnetic field was almost zero. As the phone moved closer, the magnitude began to increase. And if the phone wasn't properly aligned with the magnet, certain components of the magnetic field weren't being measured properly. There were a few possible points of error. Other electronics that were nearby could have had fields that distorted the field we were working with, and there could have been incorrect calibration and measurements when recording data. What if we hadn't oriented to compensate for the magnetic north of Earth? The Earth's more powerful magnetic field would have distorted the measurements of the smaller magnet that we were working with. And then what if two identical magnets were to be stuck together? The direction of the field at certain points would be the same, the magnitude would just double.